Now let's look at this problem one more time, but this time using rejection regions. Notice we'd again start out the same way we did last time. We'd start out with the fact that the claim is that the standard deviation sigma is equal to 6.0. That means because of the equal to symbol that would fall as our claim, our null hypothesis, which means the alternative hypothesis would be not equal to 6.0, which means again we would have a two-tailed test. We'd still start the same way. We'd list out any information given to us, which they gave us the sample standard deviation of 4.9. They also gave us a level of significance alpha of 0.01 and a sample size of 40. And again, we already said that it's going to be a two-tailed test because of the not equal to in the H1. You'd still find your test statistic using the same exact formula, the n minus 1 times s squared over sigma squared, and you'd get the same value for your test statistic, the 26.01. The difference is we would not use the 26.01 to find a p-value. We'd use this test statistic and we'd determine whether or not this test statistic is it in the rejection region. So our test statistic question is this in the rejection region? Well, we have to come up with the rejection region. Just like before, how do you come up with rejection regions? You have to use your alpha to build it. Well, so let's come up with our rejection region. Well, if we have our picture, I could draw a little picture here. And remember that the chi-squared graph is a skewed graph, best I can do there. And we have a two-tailed picture. Remember, our alpha was 0.01. That's going to be the area between both tails of our rejection region. So the question is, what's going to be the area in just one of those tails? Well, it'll be half of that. So the area in just one of these two tails for our rejection region will be half of the 0.01, which will actually be 0.005 in each one of our tails. Well, okay. The easiest one to find of our two critical values that make our rejection region is actually going to be the one on the right. So the question is why? Well, it's because remember that the chi-squared table gives you what? Areas to the right of the critical value. So if I wanted to look at this critical value here, I'd look at the area to the right of the critical value being, well, according to this picture, it's 0.05. What was our degrees of freedom? It was actually 39 because our n was 40. There is no 39 on our table, so we would use the closest. The closest to 39 on the table would be 40. So we'd use the value for 40, actually, which is 66.766. So that's the chi-squared value that makes up our upper end of our rejection region. You still need to find the chi-squared that's going to make up your lower end, your left end of your rejection region. The problem is you have the area on the left. The table wants the area to the right. Well, the area to the left was 0.005, so the area to the right will be 1 minus that, which is 0.995. So I'd actually look up 0.995 on my table. Again, I'd love to use the degrees of freedom of 39, but that isn't available on the table, so I'll use the closest, which is 40. So if I look for those overlapping numbers, I get a chi-squared value of 20.707 as my chi-squared that's going to build my lower end for my rejection region. So I have my rejection region built. Let's take a look at a kind of a prettier picture of this. we just came up with the 20.707 for our lower end of our rejection region and a 66.766 for the upper end of the rejection region. The question was, where does our test statistic fit? Remember, our test statistic using our formula came out as 26.01. Well, 26.01 is smack dab in between the two ends of the rejection region. So what does that mean? It means that our test statistic here is not in the rejection region. What does it mean if it's not in the rejection region? Remember, it means that we're going to fail to reject H naught. So let's remind ourselves what H naught was. Well, remember that H naught was that the standard deviation, sigma, is equal to 6, and that was our claim. And then we had our H1, which was that the standard deviation was not equal to 6. Remember that we're going to fail to reject H naught. Which also happens to be our claim. So remember, because we are failing to reject, that means that there will be insufficient evidence. To do what? Well, in this one, we are failing to reject. So we're going to say that there is insufficient evidence to reject. Just cross out the except because that's not what we're doing here. So there is insufficient evidence to reject the claim that the standard deviation is 6.0. Remember, this is the exact same answer that we got before. That's not a coincidence. That will always happen when we compare the answers to the p-values approach and the rejection region. The answers should always be the same. If they're not, it's because you did something wrong. Again, these two values that make up your rejection region, there's a fancy name for those two. They are called your critical values. We do actually have two critical values this time because it was two-tailed. Sometimes you will only have one critical value. That will be when you either have just a left-tailed or just a right-tailed test.